Good evening, everyone. Yeah, I think everyone came. Let's start. Okay, next we are going to start digital electronics, right? So we are studying different type of electronics. In our morning class, we are discussing about power electronics, right? And already we have been concluded. There are some other type of electronic switches that we are going to design. That is called analog electronics. And here we are going to discuss about digital electronics. See, what is the difference between these things at all? Basically, in analog electronics and power electronics, we are designing the switches, right? We are designing the switches in the sense, as I said already, you know the purpose, right? The natural available sources in this universe, the major source is available in AC, right? But there are some other major applications, right? Small power applications devices are being running at a DC, right? So there is some necessity for DC that it should be required in the application point of view. So we should maintain, right? We need DC, that's all, right? At the same time, at sometimes, like our solar panel, we have DC power, and it is not what I can say fixed DC, right? And from that, in order to obtain the proper constant DC, or if you want to convert that energy from DC to AC, we need some type of switching mechanism. That's all. There are nothing to discuss, right? A simple switch that will going to help us to chop some period, or it will change the property of the signal. Actually, நம்ம என்ன பண்றோம் conventional, we are not doing some magic things here, right? Yes, we have seen it, right? Just a switching mechanism use பண்ணி ஒரு சைனசாய்டலா வர சிக்னலை ஒரே போலாரிட்டியா நம்ம மாத்தணும். That's what we are doing in power electronics, right? Even in analog electronics also, we are going to do the same thing, but power electronic devices are bulky power devices, right? Bulky power in the sense they are going to drive DC machines, AC machines, we saw already, right? And in HVDC transmission line at all, we are trying to transmit the power in the level of 400 kilowatt, I said, right? So the conclusion is what here? Power electronics devices are bulky power devices. Analog electronics, we are going to design some small power applications like in the home, that is in our home applications, we are using remote, mobile, laptop, whichever the things that we are using. Some electronic devices are there now, they are being, right, designed with the help of analog switches only. We will see that things later. Okay, fine. Then what we are going to discuss in digital electronics, it is majorly depends on signals and system only. Already we have been designed, that is we have been seeing some type of signals and some type of systems, and we saw the methods to analyze them, right? In continuous domain, why we are keeping the signal; in discrete domain, why we are keeping the signal. Hey, what is the difference between continuous domain and discrete domain? I said in digital electronics I will conclude something about the digital signals at all, but in signals and system we are going to discuss about only continuous and discrete time signals. That is what I have been concluded, right? Anyway, we are in digital electronics, there is a necessity of discussing about digital signals, right? First we should think why we are discussing about this digital electronics. A very simple answer for this question. As I said, in signals also, let me raise the question once again. Why we are discussing about discrete domain? What is the necessity? How do we have signals in continuous domain? What is the purpose of discretizing them? The only reason is we are not having huge type of, that is the size of devices in order to store the infinite value of signals, right? In my speech signal itself, that is what we saw, right? Now பேசிட்டு இருக்கேன், you people are just receiving that signal, right? Now இப்போ இந்த சிக்னல் வந்து நீங்க ரிசீவ் பண்றீங்க அப்படின்னா you cannot, இப்போ அந்த சிஸ்டம் வழியா டிரான்ஸ்மிட் ஆகும்போது we cannot transmit that infinite signal. We have to sample, right? அதில் என்ன பண்ணுவாங்க அப்படின்னா டிஸ்கிரிட் பண்ணிட்டு சாம்பிள் எடுத்து and then we are merging them together. right? So the thing is what? In your devices, right, in our devices, we are unable to store infinite amount of samples. In order to let them to be finite, we are going up with that is we are discretating the system, right? So that is the modern electronics, we can say like that, because the advanced technique, it will going to overcome the sizes, right? See, the biggest advantage is digital electronics the purpose anyway, we are going to design some type of circuits we are going to design LED bulbs. Here also we are going to design switches only. One thing you all have to understand, here also we are going to design switches only, and we are going to understand the properties of memories. But don't think back is not there. Digital electronics அப்படிங்கிறது ஒரு செப்பரேட் சப்ஜெக்ட் அப்படிலாம் திங்க் பண்ணாதீங்க. சிக்னல்ஸ் சிஸ்டம்ல நம்ம என்ன கற்றுக்கிட்டோம், யூனிவர்ஸில் வந்து நிறைய சிக்னல்ஸ் இருக்கு. பேசிக்காக என்னென்ன மாதிரியான சிக்னல்ஸ்லாம் வந்து நம்ம கெஸ் பண்ண முடியும் அப்படிங்கிறத நம்ம சிக்னல்ஸில் கற்றுக்கிட்டோம், ரைட்? அண்ட் தென் வி saw I learned many things in continuous time domain, but I had a problem in continuous time domain. I was unable to store them into the device. I understood there are many signals available in this universe, but how can I use them, right, in my system? How can I store that much of samples? That's why we had been discussed about one more type of conclusions. Now we know how to convert that signal from continuous domain to discrete domain, right? Yes. Then and then நம்ம என்ன பண்ணணும், we have to store them, right? அப்போ அதுக்கு பேக்ல ஆக்சுவலா யார் இருப்பாங்க அப்படின்னு பார்த்தீங்கன்னா, once again we are going to keep transistors only, right? So switches, right? அங்கே இங்கே நம்ம யூஸ் பண்ண போகிறது switches தான். At some places we are going to store the informations, at some places we are not going to store any informations. We had been discussed about static and dynamic system. I hope you all remember that things, right? When I was discussing about the static and dynamic system, what is the difference between static and dynamic system? Static in the sense there is no memory capacity, so we are going to see those type of circuits also, and we are going to design dynamic system. Dynamic meaning we are going to store some informations, right? Past la irundha some informations vechi நம்ம future வந்து guess பண்றது, right? So that things are we will see one by one. So finally what I would like to conclude here, signals and systemல நம்ம signals learn பண்ணியாச்சு, அதை எப்படி discrete பண்றது அப்படிங்கற methods லாம் நம்ம learn பண்ணியாச்சு. So our next task, we have to let them to store in the system, right? அப்ப அந்த system குள்ள store பண்ணும்போது இப்போ நம்ம என்ன பண்ண போறோம் அப்படினா, again I had a problem. The problem is ஒரு continuous time domain ஒரு signal வந்து நம்ம discrete வந்து மாத்தறோம் அப்படினா, discrete மாத்தறதுக்கு அப்புறம் when we are looking at the y axis, guys listen, in samples, in sampling theorem I took some example. For example, I am taking some random signal like this. Now let us discretize this signal. இப்போ நான் இந்த signal வந்து discrete பண்றேன் அப்படினா, in y axis only we are taking the samples. Do you remember? In y axis I take 0, and then I took the second sample at n equal to ts, and then I took the third sample at n equal to 2ts with the help of impulse train, right? I hope you all remember. And then at 3ts, like that, in the x axis we are discretizing the signal. It means in between 0 and ts we are not considering any informations in x axis, only at ts and gathering information. Again, in between ts and 2ts we are not gathering any information from x to y axis. Again, in between 2ts and 3ts we are not gathering any information. Only we are keeping our concentration with the integer values like 0, ts, 2ts, 3ts, 4ts and so on. Similarly, we can also do the same thing in the left side also. Now the problem is, when I am looking for y axis, the data that we are collecting from the y axis is not sampled in case of discrete signal, right? நம்ம என்ன பார்த்தோம், x axis ல மட்டும் தான் இந்த மாதிரி நம்ம sampling பண்றோமே தவிர I did not talk about to the y axis, right? Now if you are repeating the same thing in the y axis also, like 0, and then at 0.5 I am considering value, and then at 1 I am going to consider, at 1.5 I am going to consider the corresponding magnitude of any signal, some general signal. It means in between 0 and 0.5 we are not going to gather any information. From 0.5 to 1 we are not going to gather any information. So the major difference between discrete and digital signal is, in digital signal y axis also sampled as well as x axis also sampled, whereas in discrete signal only y axis will be sampled. We are not touching the y axis. Clear? Yes. So we are entering into digital domain now. First என்ன பார்த்தோம், I took continuous signal. Later I had a problem, I was unable to store this much of information into the system, so I had started discretizing the x axis. Then that signal was called what? Discrete signal. Again I had a problem with the y axis. Now I am discretizing y axis also. Now I am feeling very happy because in x axis I had a sample value, sampled version of the value, finite values, right? In y axis also we have finite values. Like that we can store. Now I can store all the informations into the system. Again the thing is, after collecting this all data, people had invented. With the help of the switching combinations, we are trying to transform these informations from discrete in digital domain, from discrete domain to digital domain. In digital domain, we are going to store this information happily, right? See, we all know our number system won't have what I can say. No, number system is the divergent system. Why? Because in number system, we can go up to infinity. Is there any finite point for the number system? Like what I will tell you now, I am starting from minus infinity. Okay, just I'm starting from 0. Can you tell like that, sir, in the number system வந்து பாத்தீங்கன்னா நம்ம videos like this like 0 1 2 3 இந்த மாதிரி ஸ்டார்ட் பண்ணி இது போய்ட்டு ஒரு 1000 ல முடிஞ்சிரும் சார், இல்ல ஒரு 1 lakh ல முடிஞ்சிரும் சார், இல்ல ஒரு 10 lakh ல முடிஞ்சிரும், 1 crore ல முடிஞ்சிரும், 1 billion ல முடிஞ்சிரும், 1 trillion ல முடிஞ்சிரும். Can you say like that? Even at the infinite also we cannot define the value. So there is no in number sequence lo எனக்கு ஒரு finite dataவே கிடையாது. I can travel up to infinity. So the data that we are going to store, that is called decimal values, right? Now we are considering 0 1 2 3 4 5 6 7 8 9. இந்த 0 ல இருந்து 9 குள்ள நம்ம கன்சிடர் பண்ற நம்பர் தான் திரும்ப ரிப்பீட் ஆகும். That things we all know, right? So 0 குள்ள இருந்து 9 வரைக்கும் என்ன டேட்டா வருதோ அதே தான் திரும்ப என்னவா மாறும்? 10 11 12 13 14 15 அது எல்லாம் கூட அந்த நம்பர் சீரிஸ்ல என்ன வரும்? Again it will be the combination of what? First 9 numbers, first 10 numbers 0 to 9, right? So the conclusion is what? We have to think, sir, once again the problem is, okay, now I have finite data. Is there any easiest way to store these samples into the system? Because in decimal, I can also consider all type of values, right? And all type of combinations. Like at sometimes you may have some larger value, like 0 1 2 3 4 5 6 7 8 9 9 7 3 6 4 3 2 4 5 6 7 9. Like that, if I have big values, is there any simple way to store that information into the system? We are thinking, right? Yes. So finally we found one more domain, that is digital domain. In digital domain, we are going to consider all these values in terms of binary products, right? Binary, simply we can say binary. What do you mean by binary? In that binary, we are going to consider only 2 digits. That's the beauty of your digital system, you know. We are going to consider only 0 and 1, that's all. There are nothing to learn in that, right? Only with this, the entire subject, it's only depending on these 2 persons. We are going to play with it like a game, right? Whichever things that we are ஒரு கேமை டவுன்லோட் பண்ணி நீங்கள் என்ன ப்ளே பண்ண போறீங்களோ that is what we are going to do in digital learning. Because once I am entering into the sequential circuits, then you will come to know about that is beauty of these circuits, how the way we are going to design the circuit, how beautifully your bits are going to be transmitted from one point to another point. Happily, like it will trigger something. Our brain is automatically being simulated to this type of logic sequence because there is nothing to learn. It's very easiest subject, right? Let's see, right? The digital learning is also one of the scoring subject. There are nothing to learn. At the end of this session, you will come to know, because you know one thing, in power electronics at all, there might be some formula that should be required to remember some big formulas. If you forget something, நம்ம என்ன பண்ணுவோம்னா ஒரு சில ஃபார்முலாஸ்லாம் மெமரைஸ் பண்ற தேவைகள் தேவைப்படும். நீங்க திங்க் பண்ணுவீங்க, நான் மெமரைஸ் பண்ணி வச்சுக்கிறேன், I don't want to waste my time like that. But in digital electronics, very few formula that things also not required in order to memorize. By practice that will be stored. Like I can count it. The formulas are 5 to 6 formulas. Only your brain has to work there. You can play. You have to take some circuit and you have to let the sequence pass some 0 1 0 1 1 0 1 1 combination, and we should play with this circuit. That's the beauty of our digital electronics, right? I hope, right? Yeah, it's quite interesting. We will see the things later. Okay, let us start. So we are been discussed about analog signals. We have been discussed about the discrete signal. Right now we are going to discuss about the next type of signal, that is called what? Digital signal, right? So I am giving introduction for the next type of signal, that is called digital signal. In this digital signal, we are going to consider only 2 beautiful persons. They are 0 and 1. That's the beauty of our system, right? So the conclusion is, now we are going to transform our data from decimal domain to other domain, that is digital domain. In digital domain, we are going to consider some different type of numbers. You might think, the thing is, after decimal abdina, we know that value we are going to consider 0 1 2 3 4 5 6 7 8 9. Totally how many numbers are there? 10 numbers, including 0. We will have 10 numbers, right? So this decimal system, if you have any combinations or any series in decimal in the sense normal representation, number representation, right? So I said I would like to transform this data from decimal domain to digital domain. In digital, இப்போ நீங்க கிளாக்லாம் பார்க்குறீங்களா, நம்ம எவ்வளோ டிஜிட்டல் தான் எல்லாமே. நீங்கள் வெளியில் போனீங்கன்னா நம்ம டிவியில் பார்க்குற ஆட்ல இருந்து நீங்கள் வெளியில் இப்போ இந்த பஸ் ஸ்டாண்ட் சைட்லாம் பார்த்தோம்னா நிறைய ஆட் வந்து இப்போ ஓடிட்டு இருக்கும், டிஜிட்டல் போர்ட்ஸ், ரைட்? இன் யூடியூப் சொல்லவே வேணாம், ரைட்? ஹவு மெனி ஹேட்ஸ் ஆர் பிளேயிங், ரைட்? வீடியோஸ் நம்ம வாட்ச் பண்ணுறது, யூனோ ஆல் ஆர் பைனரி டிரான்ஸ்ஃபர்மேஷன், ஆல் ஆர் டிஜிட்டல் டிரான்ஸ்ஃபர்மேஷன், right? Digital is overcoming, right? It will overtake the entire world, right? So the conclusion is what I would like to represent. From a digital number represent from data, we are going to use different codings, different combination of number system, right? So in that way, when we are transforming from data from decimal to digital domain, in digital domain, first I am introducing the first person, that is called binary, right? So we are going to use binary. In binary, we are going to talk about only two digits. One is 0 and another one is 1. So happily we are going to consider only these two digits, 0 and 1 is simply called binary values. Clear? So again, people had created some revolutions. We have to write like what I can say. We have 0, 1, but we have to increase the data storage. Abhina meaning 0, 1 abhina, with the help of 0, this 0 will be simply represented as 0 here. This 1 is simply represented as 1. If I have some other value 2, 0 க்கு நம்ம அப்படியே 0 ன்னு எழுதலாம், 1 க்கு அப்படியே 1 ன்னு எழுதலாம் பைனரி சிஸ்டம்ல. Now if I have 2, இப்போ 2 ல இருந்தா எப்படி சார் இத ட்ரான்ஸ்ஃபர் பண்றது? Again people are thinking we have to increase the number of what I can say, we need some other combination, some other conversion, some other number series should be required, right? Like that, this is binary system. Let me introduce the next system, second system, that is called nibble system, right? What is the purpose of this nibble? Nibble in the sense we are going to consider 4 people. Happily we can go up to, like let us consider once again this person will going to bring out the values from 0 to 3. We can consider under nibble 0 to 3 in the sense, see, in binary we are going to consider only 0 and 1, that is for binary. Now for nibble we are happily going to travel up to 3. So 0, 1, 2, 3, total I have 4, right? So its base is called 4. 4 denotes the number of people that we are going to consider here, number of set of combination, right? So here in case of binary the base is 2. Why I am considering only 2 people, 0 and 1? Whereas in nibble system I am going to consider 4 people, right? One is 0, 1, 2, 3. But in digital, how we are going to represent them, right? So I will explain, right? So in digital, in case of nibble system, its equivalent value can be written as 0, 0. First thing, right? For 0, its equivalent value in nibble, right? The nibble representation, right? In nibble number system, 0 can be represented as 0, 0 because we are going up to 4 numbers. I need 0, 1, 2, 3. I have to represent these 4 people, right? So how many bits that it should be required for me, right? See, if you want to simply represent 0, then 1 bit is sufficient. And next, if you want to represent 1, then 1 bit is sufficient. But if you want to represent 2, then I need of 2 bits. Then I need of 2 bits, right? So the conclusion is, see, let me represent. Generally, it can be represented as 2 power n. Here, n denotes the number of bits, right? So n denotes the number of bits that it should be required to, that is bring out the sequence, right? If I know so see there, just to replace n equal to 1 here, n equal to 1 potting abdina, you will get 2 numbers, right? n equal to 1 potting abdina, we are getting 2 numbers. They are called 0 and 1. That is called a binary system. If I am putting n equal to 2, if I am putting n equal to 2, then 2 power 2 will give you 4. It indicates, this 2 indicates the base of the system. It means in that system we can represent only what? 2 people, right? Whereas n equal to 2, if I am putting n equal to 2, see 2 denotes the number of bits. With the help of 2 bits, we can write 4 numbers. So that 4 is nothing but base. Clear? So 4 denotes the number of people that are going to be lies, right, under the system. So the conclusion is what? It is called base. In that base system, how many bits we can consider? 0, 0. So for each and every person, we are going to consider 2 bits. Like that, the first person can be written as, that is for 0 we are using 2 bits because 0 equivalent value will be 0, 0. For 1, its equivalent value will be 0, 1 in digital. Right? For 2, its equivalent value will be 1, 0 in digital. Right? And for 3, its equivalent value will be 1, 1. Clear? Such that we are representing 4 values here in case of nibble system. Let us continue our discussion. Again, I am not sufficient with this, right? We should travel with some other values. Let us increase the complexity, right? Now, there will be one more system that is called, I am introducing the next system. I think, yeah, things are visible for you all. The next system that I am introducing is octal. That is, again I am expanding the discussion because we had concluded up to this. I completed my journey up to 3 only. I would like to extend the discussion, right? So in case of octal system, happily you can travel up to 7. Like you can start from 0, you can run up to 7. In case of octal system, we are going to consider 7 people. So it's not 7 people. We are going to travel up to 7. Such that 0 to 7, we are going to consider 8 people. Number of people are 8, and the maximum value is 7. Its maximum value is 7, right? Such that octal, see that if I let n equal to 3, let us see if I am increasing. So my conclusion is what? N denotes the number of bits. N if number 1 port we can write 2 bits. That system is called the binary. If I am putting n equal to 2, I am getting 4 bits, right? We can consider 4 people in this case. So I am happy to say n equal to 2, it clearly indicates that we can write with 2 bits. Over person you can write 4 people here. Similarly, if I am putting n equal to 3 here, I can write 8 people. I can consider 8 people. But how many bits are going to consider? If I consider 3 bits for each and every person, over person 3 bits consider 8 people you can register. Shall we start? Yes. So in case of octal system, the conclusion is we can consider 8 people. Let me represent them here. Yeah, let me rub these things now. Slowly understand, right? Digital is the very interesting subject, right? It's like a game. Yeah. So octal system. What we are going to do in octal, I go right. We can travel happily up to 7, right? 7 in the sense 0 to 7, right? In a decimal domain from 0 to 7, that will be in octal that can be represented. Only we are going to consider 0 to 7 and its equivalent to digital value. Shall we start? Yes. In case of octal system, let me denote it. We are going to consider 3 bits for each and every person, such that it can be represented as first person can be written as 000, second person can be written as 0, we can consider 001, third person 010, fourth person 011, fifth person 100, and then they are going to consider 101, 110, 111. It is the equivalent value, right? So that is the for octal system it can be written as equivalent value of 0 is 000, equivalent value of 1 is 001, equivalent value of 2 is 010, equivalent value of 3 is 011, equivalent value of 4 is 100, equivalent value of 5 is 101, equivalent value of 6 is 110, equivalent value of 7 is 111. Like that, we can go up to 7 when I am considering 3 bits into the digital system. Let us increase the complexity. Happily, I would like to go up to, that is, if I consider n equal to 4, let us see at n equal to 4, we can go up to, that is, n equal to 4 of the putting up here. The thing is, here we can consider 2 people. One is, see there, let us see. In n equal to 4, let me introduce 2 people. One is binary coded decimal system and another one is called hexadecimal system. See, actually what is the difference between these 2 people? It's really quite interesting. See, what we are doing here, I took decimal system. Whereas these are, in decimal we are going from 0 to 9. That is the original decimal. Do you remember? We can consider 10 numbers here. We can consider 10 numbers. But see there, in binary, we found only 0 and 1 can be represented in binary. In nibble, I can go up to what? 3. In octal, I can go up to what? 7. None of these people are giving us a complete conclusion here, right? I am not getting a complete system. I am not getting a complete number system in order to go up to 10. So finally, when I am getting n equal to 4, 2 power 4 will give you 16 combinations here. Will give you 16 combinations. Yes or no? So n equal to 4 bits consider we can write 16 combinations. 16 combinations in the sense we can go from 0 to 15. Do you agree? 0 to 15 we can consider what? That is called hexadecimal system. So, but the thing is, then what do you mean by this binary coded decimal? Decimal number, yes. If in the 10 number you digital represent what is the minimum number of bits that it should be required? Just understand. Now n equal to 1 podum 0 and 1 digital represent when I am putting n equal to 2, I can travel up to 3. When I am putting n equal to 3, I can travel up to 8. But when I am putting n equal to 4, n equal to 4 bits. Over person will be happy. Okay, 4 0 4 bits you consider complete. Your system is getting completed. Digital system completed the 10 numbers represent. That is called decimal. See, binary coded decimal in the sense a complete decimal system will be binarized. Digital வந்து நம்ம represent பண்றோம்னு அர்த்தம். Right? But the thing is what? n க்கு வந்து நீங்க 4 ன்னு போடும்போது we can write 16 combinations, right? Complete நீங்க 16 combinations consider பண்ணீங்க அப்படினா that is called hexadecimal system. If you are going from நீங்க complete n equal to 4 போட்டீங்க அப்படினா this 2 power 4 will give you, we can consider 16 combinations. But the thing is, for a decimal number I no need to go decimal number system, I cannot go up to 16. It is restricted up to 10, that is 10 only I can consider, but here we can consider 16. So அப்ப என்ன பண்ணலாம் அப்படினா the 4 n equal to 4 அப்படிங்கற காம்பினேஷன்ல I need decimal system. ஆனா டெசிமல் சிஸ்டம்ல n equal to 4 போட்டா தான் டெசிமல் சிஸ்டம் வருது. ஆனா அந்த டெசிமல் சிஸ்டம்ல n equal to 4 போடணும். See, n equal to 4 போட்டா 16 காம்பினேஷன் வருது. ஆனா டெசிமலுக்கு எத்தனை காம்பினேஷன் போதும்? 10 combination is sufficient. அப்ப rest of 6 combination invalid combination. They are called invalid codes. Why? Because for a decimal system 0 to 9 is the decimal system. It is called decimal system. But இந்த decimal system என்னால என்ன பண்ண முடியல, தனியா இன்னிக்காக வந்து ஒரு பிட்ஸ் வந்து கிரியேட் பண்ண முடியல. நம்ம என்ன பார்த்தோம், n equal to 1 போட்டா பைனரி சிஸ்டம் வருது, n equal to 2 போட்டா we are getting nibble, n equal to 3 போட்டா we are getting octal, when I am putting n equal to 4 I am getting hexadecimal, I am not getting equivalent value of decimal. So இந்த டெசிமலை மட்டும் தனியா satisfy பண்றதுக்கு எனக்கு வந்து செட் ஆஃப் பிட்ஸ் கிடைக்கல. அப்ப நான் n equal to 4 போடும்போது I can go up to 10. Actually n equal to 4 போடும்போது 16 வரைக்கும் நம்மளால டிராவல் பண்ண முடியும். But for a decimal system only 10 numbers are sufficient. So rest of 6 numbers are called invalid codes in case of binary coded decimal. Clear? So in binary coded decimal you can consider 4 bits 0 0 0, right? But how many combinations we are going to consider? Only first 10 numbers 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 0 1 0 1 0 1 1 0 0 1 1 1 1 0 0, sorry 1 0 0 1 0 0 1. See there, its equivalent value is 0, its equivalent value is 1, its equivalent value is 2, its equivalent value is 3, its equivalent value is 4, its equivalent value is 5, its equivalent value is 6, its equivalent value is 7, its equivalent value is 8, its equivalent value is 9. I said only these combinations are sufficient for me. I am not going to this, I am not willing to go beyond this sequence. But the conclusion is what? In case of நீங்க அப்ப n க்கு வந்து நீங்க 4 ன்னு போடும்போது நான் என்ன சொல்றேன்னா, நீங்க வந்து 16 காம்பினேஷன்ஸ் வந்து எழுதலாம் அப்படிங்கறது நான் இன்ஃபர்மேஷன் கொடுக்கிறேன். சார் நீங்க வந்து n = 4 கன்சிடர் பண்ணீங்கன்னா நாங்க எங்களால வந்து 16 காம்பினேஷன் உங்களுக்கு ப்ரொவைட் பண்ண முடியும் அப்படினு சொல்றேன். ஆனா நீங்க என்ன சொல்றீங்க அப்படினா n = 4 போட்டா தான் என்னோட சிஸ்டம் எக்ஸிஸ்ட் ஆகுது. ஆனா எனக்கு 16 காம்பினேஷன் வேணும். அதுல வந்து நீங்க எனக்கு ஃபர்ஸ்ட் 10 காம்பினேஷன் மட்டும் கொடுத்துருங்க, ரிமைனிங் நீங்களே வச்சுக்கோங்க, அது இன்ஆக்டிவேட் பண்ணிடுங்க நான் சொல்றேன். That is called binary coded decimal system. Let us go get the next one, that is called hexadecimal. That is the actual representation. n = 4 போடும்போது we can get 16 combination. Happily we can freely run that, so that is write that 16 combination. That system is called hexadecimal. Clear? Let us write. Overriding. We are crossing the hexa, that is decimal, right? So hexa, right? After decimal we are considering what? Hexa, 6 numbers, right? So we are going. That is called hexadecimal system. Let's go. So if you want to write the hexadecimal system, let us write. So let me rub these things first, and then I will write the answer. Yeah, let us rub these things now. Let us write the hexadecimal system. So when we are looking for hexadecimal system, it can be written as, right? When we are looking for hexadecimal system, it can be written as, let us start from the beginning. First, for each and every person, I can give 4 bits. That's what I am giving, right? So 0 0 0 0, 0 0 0 1, 0 0 1 0, 0 0 1 1, 0 1 0 0, 0 1 0 1, 0 1 1 0, 0 1 1 1, 1 0 0 1 0 0 1, 1 0 1 0, 1 0, wait a minute, 1 0 1 1, 1 1 0 0, 1 1 0 1, 1 1 1 0, 1 1 1 1. How many combinations are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Happily we got 16 combinations, right? Yes. Let us write the expressions for them. So equivalent value is 0, it is equivalent value of 1, its equivalent value of 2, its equivalent value of 3, its equivalent value of 4, it is the equivalent value of 5, it is the equivalent value of 6, it is the equivalent value of 7, it is the equivalent value of 8, it is the equivalent value of 9, it is the equivalent value of 10, it is the equivalent value of 11, it is the equivalent value of 12, and it is the equivalent value of 13, it is the equivalent value of 14, and it is the equivalent value of 15. How many people are there? Totally from 0 to 15, including 0, we are considering 16. Clear? So what will be the basis? Totally, we are looking for 4 type of conversion in case of a digital domain. Yes, from what you can say time domain. I mean not time domain, from decimal domain, right? Let's see. Let us rub these things now. I hope you all are understanding these things, right? Let us rub these things. Yeah. It's really very interesting subject, right? If you quite please keep your interest, within 3 or 4 days you will fall in love with this subject, because that much interest will be created. You can create here only zeros and ones, right? With this you can play with this circuit, but you have to little practice should be required in order to crack the questions. Then only that stimulation will be created from your mind, right? Yes. Let us start our journey. So happily, the conclusion is from decimal system. We saw decimal base is 10. Decimal base is 10, and we are going to transform this value into 4 type of conversion. First we can convert it into base 2. Wait a minute. First we can convert the system into base 2, that is called binary. How many people we are going to consider? Only 2 people, right? Again, the same system can be transformed into nibble, right? In nibble we are going to consider 4 people. Yes. So same system can be transformed as what? Octal. There we are going to consider 8 people. Same system can be transformed as hexadecimal. BCD I will represent separately. I said that is not standard conversion, that is standard conversion. In this order of the sequence, so 2, 4, 8, 16, we are not getting BCD. BCD is 16 combinations or 10 combinations. First 10 combination 0 to 9. Rest of codes are called invalid codes. I will talk about that person later once again. Don't be panic, right? So that is hexadecimal. Yeah. Now, how can we write these things? Listen. When we are looking for the first person, right? First person, the representation is 2 power n. Code conversion representation, right? Number system represent 2 power n. That is the general version. Whereas when we are looking for binary system, we are putting n equal to what? We are putting n equal to, that is the first system. Now only we are going to consider n equal to 1, such that we are going to consider only 2 people. Now when I am looking for nibble system, we are going to consider 2 bits. In the sense, the minimum order you have to start from 2 power 1. If you start we are going to consider only 2 power 1, so only 2 combinations. Directly we can write like this. Whereas from MSB, you have to start from this is the most significant bit you have to start, and you have to travel towards left hand side, the way that they are representing the number system. Take 2 power n. Here, I need 4 people we can consider. It means n equal to 1, you have to start. N equal to 1, 2 people we can consider, and then n equal to 2, 4 people we can consider. So minimum we can consider 2 people, maximum we can consider 4 people, such that 2 square will become 4, right? And this 2 power 1 will become what? 2. Clear? Yes. So here, if you are putting, you can also, if you want to consider 2 power 0, you can also consider, sir, minimum value, you can also start from n equal to 0. Now, the consider, you are getting 4 to 1 4 system, right? So this system is called, 2 power 0. Least early consider we can write like this, right? So that is going to be what? 2 power 0. Such that you can start from what? 2 power 0, 2 power 1, 2 power 2. This code can be represented. That is called 4 to 1 code. So 4 to 1, they are talking about nibble system. They are talking about, okay, it was written on it, they are talking about nibble system, right? So let us consider here, right? So here this become what? Octal system. Octal you can minimum start from 2 power 0, because in your examination we have to start from 0 only. I only left the 2 power 0. 2 power 0 will start from n equal to 0, n equal to 1, n equal to 2, we can write n equal to 3, because that is the maximum combination, possible combination, right? 2 power 0 will give you 1, 2 power 1 will give you 2, 2 power 2 will give you 4, 2 power 3 will give you 8, such that this system can be considered as 8421 system. That is the coding representation of the octal system. Similarly, when you are looking for a decimal, hexadecimal system. Hexadecimal, you can start from 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Such that what I will get, that is going to be 16, right? So this combination we can consider up to 16. That is going to be 8. This is going to be 4. This is going to be 2 only. This is going to be 1 only. So that is called what? 8421 conversion system with the 16, right? 16 in the sense we can go up to F. That is the last value, right? From 0 to ff. I will write these things. Wait a few minutes. I will conclude all those things. Don't be panic. That is how we are representing the. That is how we are giving names for the system. That is codings, right? Yes. Next, what is the maximum number in case of binary system? Binary about you can start from 0. You can run up to 1. So the maximum number is only 1 in case of binary. What about nibble? In case of nibble, maximum number is 3. Do you agree? Yes. We can start from 0. We can run up to 1, 2, 3, such that the maximum number that it could be represented in case of nibble is 3. When we are looking for octal, what is the maximum number? We can go from 0 to 7. So the maximum number is what? 7. Here the maximum number is what? 3. What about this one? In the hexadecimal we can go up to 16. So the maximum number is what? 0 to 15. We can go up to 15. 0 to 15. Maximum number is what? 15. We can consider 15. Clear? I hope these things are clear to you all, right? So let us proceed further. Now, what is the next step that we are going to do now? Now we understood something, right? We understood something. That is some type of system we are going to consider in digital domain from decimal domain. If a number task enna appadina we have to do appo enakku oru number vandu decimal la irukku appadina I have to learn. இப்போ நம்ம என்ன பார்த்தோம் டெசிமல் நம்பரை வந்து நீங்க இந்த மாதிரிலாம் கன்வெர்ட் பண்ணி எழுதலாம் அப்படின்னு சொன்னோம் ரைட் we can write it in terms of binary, we can write it in terms of nibble system, we can write it in terms of what I can say decimal system, sorry octal, and we can also write it in terms of hexadecimal, right? Let us see if on the methods also we have to learn, right, how we are going to transform them from decimal to other type of conversion, that is called gwteducation. Next we are going to discuss about number system conversion, right? So number system conversion, we are going to see how to transform a number system or a decimal la irukka number adha endu நம்ம எப்படி வந்து octal la எழுதுறது அத வந்து நம்ம எப்படி வந்து hexadecimal la எழுதுறது அத வந்து நம்ம எப்படி that is ஒரு number decimal number binary la எழுதுறது everything you will see, right? So that is the general procedure. Let me teach you quickly, right? So just listen guys, decimal to any numbers, right? So the first conversion we are going to look at now is called, I have a decimal number and its radius is called 10, right? It is called base number. Some people are calling it as radius, right? Some people are calling it as radius. So we can represent it either it is called radius or it is called base, right? So in decimal we are going to consider totally 0 to 9 combinations. If you want to transform this decimal any conversion, if you want to transform it into binary with the base 2, or if you want to transform it to the octal, nibble I am not going to consider because that is rare. We are just going to consider 2 octal, and I am going to consider hexadecimal. We are going to consider hexadecimal. That's all. In hexadecimal I am going to consider 16. Just to understand the general procedure in order to transform this value. ஒரு வேல்யூ வந்து டெசிமல் இருக்கு அப்படினா அத வந்து நான் எப்படி பைனரி கன்வர்ட் பண்றது இல்ல ஆக்டல் எப்படி கன்வர்ட் பண்றது ஹெக்ஸாடெசிமல் கன்வர்ட் பண்றது. For example, in decimal very simple, I am taking small values. Clearly understand, there are nothing to learn, right? For example, I have a decimal number. That decimal number is given as let us take some 64. Given it is 64, right? இப்போ இந்த 64 வந்து base 10 ல இருக்கு. क्वेश्चन என்ன கேட்டிருக்காங்க அப்படினா its equivalent binary value is what? Its equivalent binary value is what? Base 2 கொடுத்திருக்காங்க அவ்வளவுதான். நீங்க equivalent value base 2 அப்படினு கேட்டிருக்காங்க. Base 2 பார்த்த உடனே உங்களுக்கு தெரியும் they are asking what? Binary equivalent. Very simple. Just take that value, right? So let me write like this, guys, listen. Let me write like this. 64 point, right? 64 point. Let us consider 10. That's enough. 64.10, or we can take some small values like 4. That is enough, right? 40. They are given some values, right? Like in the மாதிரி கொடுத்துருக்காங்க அப்படினா base 10 இருக்கு, decimal இருக்கு. How to transform any values, right? Decimal வந்து நீங்க எந்த கன்வர்ஷன் கன்வர்ட் பண்ணாலும் சரி, you can transform it into binary or octal or hexadecimal, it does not matter. The generalized procedure is just to take that number, right? அந்த நம்பர்ல fractional values வந்து இருக்குதுன்னா if there is no fraction, don't be panic. Anyway, fraction க்கு முன்னாடி இருக்க வேல்யூ இல்லையா, if you find any number that is here I have 64, that is fraction க்கு முன்னாடி இருக்க, that is integer value, whereas its fraction value is 0.40. தனித்தனியா பிரேக் பண்ணிக்கோங்க, right? இப்போ என்ன பண்றீங்க அப்படினா see there 64 இருக்கு இல்லையா, that is proper integer value. I have to transform it into equivalent binary value. If you want to transform it from what I can say the binary நீங்க கன்வர்ட் பண்ணனும் அப்படினா binary ஓட base எவ்வளவு 2, just to take this number divided by corresponding binary, right? அதே மாதிரி என்ன பண்றீங்கன்னா fractional ஓட வேல்யூ என்ன பண்றீங்க அப்படினா யாரை கன்வெர்ட் பண்ண போறீங்க from decimal to binary. அப்ப பைனரியோட வேல்யூ பைனரியோட பேஸ் ஆல இந்த மல்டிபிள் பண்ணனும். You have to multiply by its equivalent binary value, right? So the conclusion is what? Here we are going to do multiplication, here we are going to do division. General procedure I am repeating once again. கவனிங்க, ஒரு நம்பர் வந்து டெசிமல்ல இருக்கு அப்படினா அது எனி நம்பர். If you want to convert into binary or octal or hexadecimal, it does not matter. First thing, டெசிமல்ல இருந்து நீங்க பைனரி எந்த நம்பர் சிஸ்டம்க்கு நீங்க கன்வெர்ட் பண்ண போறீங்க அதோட பேஸ் எடுத்துக்கோங்க. அதோட பேஸ் எடுத்துட்டு கொடுத்திருக்க நம்பரோட இன்டிஜர் அதோட பேஸால டிவைட் பண்ணுங்க. அதே இடத்துல ஃபிராக்ஷனல் வேல்யூஸ் கொடுத்திருந்தாங்க அப்படினா ஃபிராக்ஷனல் தனியா வெளிய எடுத்து அதே பேஸால மல்டிப்ளை பண்ணுங்க. யாருக்கு கன்வெர்ட் பண்ண போறீங்க? பைனரி. அப்ப பைனரியோட வேல்யூ வர நீங்க அது பண்ணணும். Clear? That is the general procedure for all numbers. Let us proceed. So the conclusion is with this 64, if I divide it by 2, 2 ஆல டிவைட் பண்ணீங்கன்னா we are getting 32. Again you can divide by 2 now. Yes. இத எத்தனை டைம் நீங்க 2 ஆல டிவைட் பண்ண முடியுமோ you have to proceed. See there 32 ஆல டிவைட் பண்ணீங்கன்னா 32 2 into 32 will give you 64. Remainder is 0. Proceed. Again 2 ஆல டிவைட் பண்ணீங்கன்னா 16 times of 2 will become 32. Remainder 0. Repeat. Again 2 ஆல டிவைட் பண்ணீங்கன்னா I am getting 8. 8 times of 2 will give you 16. Remainder 0. Again repeat it. 2 ஆல டிவைட் பண்ணீங்கன்னா we are getting 4. Remainder 0. Again divide by 2. Right? Is it visible? Wait. Yeah, it's visible. Good. So again if I repeat it, 2 times of 2 will give you 4. Remainder 0. Again if I repeat, 1 times of 2 will give you 0. Now see there, start from the bottom, last value, right? I'm going to start பண்ணி you will have to travel like this. You will have to start from the last bottom value. We have what? At last I have 1. That is the first value from the LSB, and then you can proceed further. And then the next value is 0. அதுக்கப்புறம் மேல யார் இருக்கா? You have to travel in the upward direction. Like that 0 0 0 0 0 0, right? I have to consider 4 more zeros. So totally 1 2 3 4 5 6 1 2 3 4 5 1 2 3 yeah 4 5 6, right? So this is the equivalent value of the given 64. Now what about the equivalent value of fraction value? Fractional matters multiplied by 2. Let us take that fraction value 0.4 multiplied by 2 such that what I am getting 0.8. நீங்க ஃபிராக்ஷனல் இருக்க வேல்யூவை 2 ஆல மல்டிப்ளை பண்ணும்போது லிசன் இத 2 ஆல மல்டிப்ளை பண்ணும்போது உங்களுக்கு என்ன வருது பாருங்க. இந்த ஃபிராக்ஷனுக்கு முன்னாடி என்ன வேல்யூ வருதோ அத மட்டும் செக்ரிகேட் பண்ணிக்கோங்க. 0 வந்தா 0. Again take this 0.8 multiplied by 2 we are getting 1.6. Again collect டாட் முன்னாடி என்ன வேல்யூ இருக்கோ அத கலெக்ட் பண்ணிக்கோங்க. 1. Again select 0.6. 1 வெளிய எடுத்தீங்கன்னா again 0.6. 0 வெளிய எடுத்தா அங்க 0 தான இருக்கும், right? So see there 0.6 again multiplied by 2 such that what you are getting 1.2. 0.6 times of 2 will give you 1.2. Again correct 1. Again take 0.2 multiplied by 2. It is going to be what? 0.4. Again correct this 0. Like that you can take many values, but in particular examination they will consider only some 3 values or 4 value after fraction. But in this case இப்போ நீங்க இதுல fraction value you have to travel in the downward direction. See, integer நம்ம என்ன ஃபாலோ பண்ணுவோம்? For our integer we are dividing the integer values by the base. அதுக்கப்புறம் என்ன பண்றீங்க? லாஸ்ட் வேல்யூல இருந்து ஃபர்ஸ்ட் வேல்யூக்கு வரீங்க. இதுக்கு அப்படியே ஆப்போசிட் தான் ஃபிராக்ஷனல். இங்க டிவைட் பண்ணா இதுக்கு மல்டிப்ளை பண்ணோம். இது வந்து பாட்டம்ல இருந்து டாப் வரீங்க, இது டாப்ல இருந்து பாட்டம் போகும், ரைட்? இப்ப டாப்ல ஃபர்ஸ்ட் வேல்யூ யார் இருக்கா? See there, put a dot in the digital domain. Dot has to start from the first value 0, next value 1, next value 1 0. That's enough. That is the equivalent binary value for the given system. So its answer is, the correct answer is 1 1 2 3 4 5 6 dot 0 1 1 0. That is the binary equivalent value for the given decimal system. Suppose for the same system, if you are requested to, right, same system is given, but you are requested to find out the equivalent. Let me take some other value, right? What we can consider. Okay, why not? Let us go similar. Adhe eduthukom appo puriyum, right? So again I have this system. Same system ku enna ketirukanga, you are requested to find out the procedure remains same. Decimal la irundha neenga endha system ku convert pannalum idha procedure. But what is the base here? Base is 8. In previous case base is 2, right? And the base 2 irundadala idha nama 2 ஆல டிவைட் பண்ணோம். Now my base is what? 8. But you have to repeat the same procedure, but with the what? Instead of having 2 we have to consider 8. Shall we start? Yes. Let us start the procedure now. Let me run these things. Understand, it's very easy actually, right? It's really very easy, but you have to understand. That is what we want. Let us see. Next what I am going to consider? Equivalent octal value. Again take the same value, properly break them. Integer, fractional. 0.40 is the fractional. What is the procedure? Integer value 8 ஆல divide பண்ணு, because base is 8. Whereas fractional value could be multiplied by 8. First step. இப்போ இத முடிச்சலாமா? 8 ல 8 ல divide பண்ணிட்டோம்னா 8 times of 8 I hope it will give you 64. 8 into 8 will give you 64. Remainder 0. Again if I divide it by 8, 1 times of 8 will give you 8. Remainder is 0. Again start from the bottom, travel towards the upward such that it is become 1 0 0 dot. Why I am putting dot? Because I am going to consider fractional value. When I am considering 0.4 and I will have to multiply by 8. Correct? This 8 ஆல multiply பண்ணீங்கன்னா for an example see that 0.4 times of 8 will give you 32, right? So we can say that is 3.2. Collect the first value, put it in the outside. Collect the first value, put it in the outside. Again, if I consider next person 0.2. இங்க 3 value எடுத்தீங்கன்னா 0.2 தான் இருக்கும். Take 0.2, repeat. 8 ஆல multiply பண்ணீங்கன்னா it will give you 1.6 because twice of 8 is 16, na? Right? Again, collect 1 outside. Take fractional value, repeat the same procedure. 8 and you are going to get what? 6 times of 8 will give you 4.8, right? And you can collect it outside such that after collecting all these samples, travel in the downward direction, collect all these values. They are going to be 314. Happily, I have did the conversion, right? So when I made from 64.440, if you want to convert it into equivalent octal you represent பண்ணோம்னா for 64.40 equivalent value is 100.314. I hope things are clear. Just understand the procedure. Don't let's say consider these things at all. Okay, just understand the procedure. That is enough. What is the next task? Suppose we given it is hexadecimal. Same system is given it is like this. 64.40 we are considering. But the question is find the equivalent hexadecimal value. What can you do? Repeat the same procedure. Repeat the same procedure. Right? The procedure is remains same. The procedure is remains same. It's quite interesting, right? Let's start. Again start the journey. Integer, fraction, breakdown. First, whereas integer will be divided, fraction will be multiplied. Step number 1. Shall we proceed? Yes. Now, how many 16s are there in the 64? I have 4. Do you agree? 4 times of 16 will give you 64. Remainder will be 0. Just start with this. You cannot go beyond this. That's all right. Start from the bottom. So its equivalent value will be 40. அதுக்கப்புறம் பர்கர் அவங்களால டிவைட் பண்ண முடியாதுல்ல, right? So you will have to start with this, right? So the next thing is this is 40. Again put the dots, right? Consider this fraction value, that is 0.4 into 16. When I multiply it by 0.4 or 16 ஆல மல்டிப்ளை பண்ணீங்கன்னா 4 times of 16 will give you 6.4, right? It will be equal to 6.4. So segregate 6 outside. Again take 0.4. Right? Again, if I multiply it, again I am going to get 6.4. Happily, we got some small values, right? Again, you can segregate it. If you repeat the procedure, again you get 666 only. So the conclusion is what? It is going to be 40.666. So its equivalent value is going to be 40.6666. And you can go fractional value நிறைய போலாம், but exam ல பாருங்க it will be restricted only up to some 2 or 3 decimals. You don't need to go beyond that. Clear? So that is how we are happily transforming, that is transforming any into any domain from decimal, right? So we are doing this conversion from decimal to any domain. Now my second question is second type of conversion is suppose I have values in binary or I have octal or hexadecimal. Opposite case, reverse the process, any domain to any number system to decimal. What is the conversion process, right? Let us see. The process is I have binary or octal or hexadecimal. I would like to get its equivalent value, right? Into equivalent decimal. எனக்கு இதுல இருந்து ஒரு equivalent decimal வேணும் அப்படினா what I need to do? Shall we proceed? Yes, let us see. Yeah, let me have these things. Okay, let us see any domain to decimal domain. Any domain in the sense, shall we write? We can write, no problem, right? I have binary base 2, and we are going to consider octal with the base 8. We are going to consider hexadecimal with the base 16. Let us see the procedure. If I want to transform this value from binary to any values, right? Binary to any, not binary. Binary octal hexadecimal to what? Decimal. Equivalent is decimal. Let us see. First we will see this one, and then we will take the second one, and then we will take the third one. We will take the third one. Right? Now, what I am going to consider here, for example, I have a binary value. That binary value is given as, let us take some 1 0 1 0 1. they are given some value, right? We can also consider some fraction value for understanding. 101 point, let us consider 0.10. Something is given like this. Now the question is, what will be its equivalent value? It's very easy. It's very easy, right? The thing is, you all have to do is take this one. இப்போ நீங்க என்ன பண்ணீங்கன்னா once again collect 101 point, what was given 10 தான கொடுத்திருக்காங்க. இத அப்படியே தனித்தனியா பிரேக் பண்ணுங்க. Once again, proper integer value is 101 and its fraction value is 0.10. Do you agree? Yes, its fraction value is 0.10. Now select this integer. Integer value is 101. Start from the least base. இங்க base value என்ன கொடுத்திருக்காங்க 2. Actually இப்போ நம்ம என்ன பண்ணிருக்கோம், we know how to transform this value from decimal to this any number system. இப்போ நம்ம என்ன பண்ணிருக்கோம், டெசிமல் இருந்து ஒரு நம்பரை பைனரி கொண்டு வந்தப்போ நீங்க என்ன பண்ணீங்க, ஒரு நம்பர் டெசிமல் இருந்துச்சு, அதை நம்ம பைனரி கன்வெர்ட் பண்றதுக்கு நான் என்ன பண்ணேன், I went up with நம்ம எடுத்த நம்பரை என்ன ஆக்சுவலா நம்ம என்ன பண்ணிருக்கோம், கொடுத்திருக்க நம்பரை 2 ஆல டிவைட் பண்ணி வச்சிருக்கீங்க. கரெக்ட்டா? எஸ். இன்டிஜர் நம்ம எப்படி கொண்டு வந்தோம் அப்படினா, ஒரு டெசிமல் நம்பர் கொடுத்திருக்காங்க அப்படினா அதுல இருந்து பைனரி வேல்யூ வேணும் அப்படினா அந்த டெசிமல் நம்பரோட இன்டிஜர் நம்ம என்ன பண்ணிருக்கோம், 2 ஆல டிவைட் பண்ணோம். Now you have to multiply them, but in the different approach. எப்படி மல்டிப்ளை பண்ணி அங்க நீங்க எப்படி மல்டிப்ளை பண்ணிருக்கீங்க அதேதான், பட் நீங்க சாரி அங்க எப்படி டிவைட் பண்ணீங்களோ அதே process நீங்க ஆப்போசிட்ல பண்ணணும். எப்படி see that actually that multiplication, do you remember for an example I have 64. இது கவனிங்க, நீங்க 2 ஆல டிவைட் பண்ணீங்க, இது வந்து டெசிமல் வேல்யூ, இது பைனரி கன்வெர்ட் பண்ணும்போது இத நம்ம 2 ஆல டிவைட் பண்ணோம் அப்படினா we are getting 32. Yes or no? So how many times? 2 times of 32 will give you the value of 64. Again if I divide by 2, how many times will give you 16 times of 2? It means we can write இத நீங்க எப்படி எழுதலாம், 2 power 5 எழுதலாம். கரெக்ட்டா? Just observe the order. Shall I write like this, 2 power 5? அதனால நம்ம என்ன சொல்லிருந்தோம், 32 சொல்லிருந்தோம். கரெக்ட்டா? அது நீங்க திரும்ப 2 ஆல டிவைட் பண்ணும்போது we are getting 16. Equal value is what? 2 power 4. Again observe, 2 ஆல டிவைட் பண்ணுங்க, we are getting 8. What is this? 2 power 3. Again divided by what I am getting here, my order is, notice this one, 2 power 5, 2 power 4, 2 power 3, next 2 power 2 value வரும், 2 power 1, 2 power 0. So the order is, அப்ப நம்ம என்ன பண்ணிருக்கோம் அப்படினா இந்த டர்ம்ஸ் வந்து இதோட இப்போ ஒரு நம்பர் வந்து நீங்க 2 ஆல டிவைட் பண்ணீங்க அப்படினா actually we are indicating like this. இது நம்ம எப்படி ரெப்ரசன்ட் பண்றோம் அப்படினா 2 power 5, 2 power 4, 2 power 3, base is what 2. அந்த ஆர்டர் தான் நீங்க டிவைட் பண்ணி கொண்டு வந்திருக்கீங்க. கரெக்ட்டா? அப்ப திரும்ப இத நீங்க ரீகைன் பண்ணனும் அப்படினா இதே ஆர்டர்ல மல்டிப்ளை பண்ணனும். இதே ஆர்டர்னா எப்படி, see there, its first value will be multiplied by 2 power 0. Last value 2 power 0 தான் இருக்கும். Yes, you have to start from what MSB. ஏனா நீங்க bottom இருந்து top தான் வந்தீங்க, opposite தான் வந்தீங்க. கரெக்ட்டா? So start from MSB, reverse the process. Select the next value from the MSB 0, right? அத நீங்க என்னவா மல்டிப்ளை பண்ணனும், see there, 2 power 1 ஆல மல்டிப்ளை பண்ணனும். Select the third value, யாரால மல்டிப்ளை பண்ணனும், 2 power 2. Do you 1 இருக்கா? Yes, nothing is there, right? Simply you can write 2 power 0 is 1, 1 into 1 1, 2 power 1 into 0 0, 2 power 2 will become 4. Clear? So its equivalent value is what? Now let me write this one. So finally I understood. இது கன்வெர்ட் பண்ணதுக்கு அப்புறம் என்ன பண்ணா, you have to add all these values. 1 plus 0 plus 4 will become 5. So its equivalent value 101, its equivalent value should be equal to 5 decimal value. Its equal decimal value should be equal to 5. But still it is not over yet, right? We have to consider fraction value also. So simply I will say, இப்போ நீங்க எந்த சிஸ்டம், ஒரு பைனரி சிஸ்டமை நீங்க டெசிமல் கன்வெர்ட் பண்றீங்க அப்படினா அதோட பைனரியில இருக்க இன்டிஜரை இந்த ஆர்டர்ல நீங்க மல்டிப்ளை பண்ணணும். லைக் you have to start from minimum base. MSB ல ஸ்டார்ட் பண்ணி first digit will be multiplied by 2 power 0, second digit will be multiplied by 2 power 1 and then 2 power 2, 2 power 3, 2 power 4 and so on. இங்க நீங்க மல்டிப்ளை பண்ணனும், whereas here you have to reverse the process, divide பண்ணனும். Start from the first value, right? இங்க 1 இருக்கா, 0.10, right? First value இங்க 1 இருக்கு, divided by 2 power 1. Clear? See, you cannot consider 2 power 0 here also. Already it has been considered. 2 power 0 is integer value, adha neenga indha pokkum consider pannum. Whereas in the fraction value you have to start from 2 power 1 minimum value, and then second value is 0 divided by 2 power 2. But 0 by 2 power 2 will be 0. 1 by 2 will give you 0.5. So its equivalent value will be 0.5. Clear? That's all. There are nothing to understand, right? So let me write the answer finally. This is the general procedure. You can use it for all people now. You can use it for all people now, right? So let us see. So the conclusion is, appo enna conclusion, 101 இதோட equal value எனக்கு வந்தது 5 dot, that is 0.5 na 5.5, right? So 101.10 equivalent decimal value is 5.5. So correct answer is 5.5. Getting me? Very simple, right? So right side la இந்த sequence 2 power 0 ல இருந்து ஆர்டர் ஸ்டார்ட் பண்ணி மல்டிப்ளை பண்றீங்க, இங்க 2 power 1 ல இருந்து ஸ்டார்ட் பண்ணி டிவைட் பண்றீங்க, அப்படியே அப்படியே எடுத்து வந்து மொத்த வேலையை ஆட் பண்ணி ஒண்ணா போட்டுறீங்க. So if I start from octal start பண்ணி அப்படினா see there, let me take some value. Let us take 101.10. Take some value, sorry. Okay, that value is okay, let us took some what I can say 64 point, let us consider some 32. இப்போ இந்த மாதிரி வேல்யூ எடுத்து வெச்சுக்கோங்க. என்ன பண்ணுவீங்க? Again take 64 outside. Base is what? Integer மட்டும் தனியா கனெக்ட் பண்ணிக்கோங்க. Fraction தனியா கனெக்ட் பண்ணிக்கோங்க. Fractionல 32 இருக்கா? Very simple. என்ன பண்ணுவீங்க? First value 4, it will be multiplied by 8 power 0 plus second value is 6, that will be multiplied by 8 power 1. You have to start from minimum base. So 4 into 8 power 0 plus 6 into 8 power 1. What is the equivalent value? 4 into 8 power 0 will become 4. 6 times of 8 will be 48, such that it will be equal to what? 52. Clear? So integer value is 52. Dot. Second முடிச்சலாமா? Fraction value என்ன பண்ணனும்? Divide பண்ணனும். 3 by 8 plus 2 by 8. இது ரெண்டுமே fractional போட்டுட்டு you can just add them. Clear? You can just add them. That is going to be 1 by 4. That is equal to what? 0.25. Right? Similarly, you can either you cancel பண்ணி it is going to be what? 0. It is going to be, let me consider. Yeah, 0.375. அது கூட நீங்க 0. See there, here I got 0.375, here we got 0.5. Such that it is going to be what? 12 remaining, it's going to be 4, 6, 0.625. I got 0.625. That is the add பண்ணிக்கோங்க 0.625. Clear? Similarly, let me give one example. Take hexadecimal also. Let us consider some 256.3. You will do it by yourself. What is the procedure? Integer value, இத எடுத்து என்ன பண்ணுவீங்க? First 6 will be multiplied by 16 power 0, 5 will be multiplied by 16 power 1, 2 will be multiplied by 16 power 2. We can add them on. Clear? That is how we are considering integer value. What about fraction? 0.3. 3 you will have to divide by 16 power 1. If I have one more value, then that will be added with this, but that will be divided by 16 power 2. Like that, we can also add fraction values. Clear? So that is how we are transforming decimal to any values. I hope these things are very clear to you all, right? So that is how we are doing the basic number system conversions, right? Okay, guys, with this, let's wind up the today class, right? Because I have some other works, I have to go outside, right? From tomorrow, tomorrow class, we'll see the rest of combinations, right? Like we have to transform binary to octal, and octal to some hexadecimal, right? Binary to hexadecimal. That things we have to conclude. Then we will start the what I can say with this. We have to discuss about some what I can say number system conversions. நீங்க என்ன படிச்சிருப்பீங்களா? 1s complement னா என்ன, 2s complement னா என்ன, அந்த பர்பஸ் எதுக்காக வந்து இந்த காம்ப்ளிமெண்ட் அப்படிங்கிற டேர்ம் எதுக்காக வந்தது, தட் திங்ஸ் we have to conclude. With this phase 1 will be completed. Then we have to discuss about logic gates. Logic gates டிசைன் பண்ணதுக்கு அப்புறம் we will start next chapter, that is called combination circuits and sequential circuit, right? So let me conclude. Just we are looking in the, that is looking for basics. In digital electronics, we are going to cover totally 4 phases. In phase number 1, we are going to discuss about the basic number system conversions, and then we are going to develop some equivalent circuits for logic gates. Logic gates are switches. Once again, we are going to design the switches, but in digital we are going to see. நம்ம இப்ப பவர் எலக்ட்ரானிக்ஸ்ல என்ன பண்ணிட்டு இருக்கோம்? Switching combination தான் பண்ணிட்டு இருக்கோம், but electrically we are deriving the term. In digital electronics, we are going to do the same thing, but in digital, like 0101 combination, right? That's quite very interesting, right? After completing that things, we have to start combinational circuit. That is the second chapter, and the third chapter is going to be sequential circuit. Fourth chapter, we are going to see the code conversion. Like you might be wonder, திரும்பவும் எனக்கு digital, okay sir, everything is over. அப்ப நம்ம digital எல்லாத்தையுமே டிசைன் பண்ணி முடிச்சாச்சு. நமக்கு practical worldல என்னங்க இருக்கு? இப்ப நான் பேசிட்டு இருக்கிறது என்ன சிக்னல்? Continuous. That is called analog. ஒரு டிஜிட்டல் இருக்க சிக்னல் அகைன் உங்களுக்கு அனலாக்ல வேணும்னா என்ன பண்ணுவீங்க? அகைன் we have to transform. For that we need some converters, that is called analog to digital converter. அதே மாதிரி டிஜிட்டல்ல இருக்க வேல்யூ திரும்ப நீங்க அனலாகா கன்வர்ட் பண்ணனும். See, initially I have analog signal. With the help of digital devices, we are going to convert it into digital domain, and then again we are going to digital இருக்கறத திரும்ப நீங்க அனலாக் மாத்தணும். For that we are going to use digital to analog converter, right? So now we are first target is we have to design the digital system, and then output side ல நின்னுட்டு input side ல analog to digital க்கு எப்படி கன்வர்ட் பண்ணி அதுக்கு அப்புறம் சிஸ்டம் குள்ள பாஸ் பண்றது, அவுட்புட் சைடுல டிஜிட்டல்ல இருந்து வெளிய எடுத்து எப்படி நம்ம திரும்ப அனலாக் கன்வர்ட் பண்ணனும் பார்க்கணும், ரைட்? And apart from that we should discuss about the basic properties of the memories. மெமரிஸ்னா என்னங்க, that is logic people, logic gates. நான் சொல்லியிருந்தேன் இல்லையா, in digital electronics they are going to design two type of devices. One is called a static device and another one is called a dynamic device. So the difference is, in static device we are going to, there is no memory. Static என்னன்னா present. இப்போ நான் பேசுறது உங்க மைண்ட்ல கிளாஸ் முடிஞ்ச உடனே வெளியில போயிடுச்சுன்னா that is static. But it won't happen like that, right? For our system is dynamic system. அப்போ நம்ம second device we are going to discuss about dynamic. In what I can say, memory system, logic families அப்படின்னு சொல்லிட்டு ஒரு டாபிக் நீங்க செப்பரேட்டா படிச்சிருப்பீங்க இல்லையா? In logic families, that is what we are going to see. We are going to decide, that is discuss about some memory elements and what is the basic properties of memory elements. Actually what we are doing in MOSFET and BJT et al, how they are working as a switch. Digitally we have to look at them, right? After completing, that's all. There are no more things to discuss in case of that is in digital electronics, right? With this, let me wind up the class. Rest of things we will see tomorrow, right? Thank you all.